A heating element using nichrome connected to a 230 volt supply draws an initial current of 3.2 ampere, which settles after a few seconds to a steady value of 2.8 ampere. What is the steady temperature of the heating element if the room temperature is 27 degrees Celsius? Temperature coefficient of resistance of nichrome averaged over the temperature range involved is 1.7 into 10 to minus 4 degrees Celsius inverse. Okay, so in the solution, let's write the data which is given over here. So here you can say voltage supply V is equal to 230 volt. Okay, initial current is 3.2 ampere. Okay, let it be I1. So I1 is 3.2 ampere, and after a few seconds current reaches to a steady value. Let it be I2, and that is equal to 2.8 ampere over here. Here the reference temperature, which is room temperature, T0 is 27 degree Celsius. Okay, then after we have the value of alpha also, and that is equal to 1.7 into 10 to minus 4 degrees Celsius inverse. Okay, so here we have the value of voltage and the current. So when voltage is 230 and current draws 3.2 ampere, let value of resistance is R1. So we can say initial resistance, let it be R1. R1 is equal to V by I1. Okay, so V over here is 230. So 230 divided by 3.2, we will get the answer 71.87 ohm. Okay, then after in this problem current reaches to steady value I2. Okay, so final resistance, we can write final resistance at steady value of current I, let it be R2 is equal to V by I2. V is 230 volt over here and current is 2.8 ampere. So after solving this term we will get 82.14 ohm. Okay, so now we have the value of resistance R1 and R2. We have the reference temperature T0, and we have to find the temperature at a steady current. Okay, so we have to find a steady temperature. Okay, let it be T. Okay, so we have to find T when resistance is R2. Okay, now let's solve this problem. So over here we can say from the equation R2 is equal to R1, 1 plus alpha T minus T naught. We have value of R2, R1, alpha T naught. We have to find this T. So let's make T minus T0 a subject. So we can say T minus T0 is equal to R2 minus R1 upon R1 alpha. Okay, value of R2 we find that is 18 to 82.14. Value of R1 is 71.87 divided by R1 alpha, so 71.87 into alpha over here is 1.7 into 10 to minus 4 degrees Celsius inverse. Okay, now after simplifying this term we will get the answer 840.5, means 840.5. so I can write T minus T naught. T naught is 27, which is room temperature, or you can say reference temperature. So T minus 27 degrees Celsius we can say is equal to 840.5. so T is equal to 840.5 plus 27 degrees Celsius. So our final answer becomes T is equal to 867.5 degree Celsius. So we can say The steady temperature of heating element is 867.5 degree